For this problem set, we're going to be looking at how you add forces, and you're going to get to try a problem from each of the three different methods. So let's start with the simplest method. And for this method, if I give you a force 1 and a force 2, you should be familiar with this method by now. Use the parallelogram method to try to sketch out what it's going to look like. Well, you add force 1 to force 2. You're not going to get any hard numbers, but you might be able to at least get a sense. So pause the video if you need, take a second, and then we'll go through it. So let's look at what we have. We draw force 1, and then on the tip of it we draw force 2. And we do the correct join, tip to tail. So we have 1 and 2. And now we can draw in our new vector, which goes from 1 to 2, like this. And if we want to, we can verify that it works in reverse. 2 goes this way, 1 goes this way, and we get the same answer. So we've successfully computed force 3. So the parallelogram method is the easiest. So now let's move on to one that's a little bit trickier. So for this one, you have to add together the three forces, and the forces are given to you as 2D vectors. And if you're not familiar, this I hat and this j hat notation just means the x and the y coordinates. I hat corresponds with x, j hat corresponds with y, and it lets you know which direction the vector is going. So given this, what would you expect be the vector that's the sum of vectors 1, 2, and 3? So pause the video, solve it out, and then we'll go through it together. So going through this, what we see is force 1 plus force 2 plus force 3. We're going to have to add the I components, and then we're going to have to add the j components. So we'll start with the I components. It's 7I hat minus 2I hat minus 5I hat. 7 minus 2 minus 5 is 0. So 0, still need the I hat, because it's telling you which direction is it 0. It might not be 0 overall. So now let's do the j hat component. That's just 3j hat plus 4j hat minus 4j hat is 3j hat. And I've been writing i's here, I should be writing j's. So now we have our answer. It's as simple as that. It's 0i hat plus 3j hat. And if you wanted to, if you're motivated, it's pretty easy to sketch out these vectors. Force 1 is going 7 in the x direction, 3 in the y. Force 2 is going -2 in the x, 4 in the y. You can sketch these out. And then you can do the parallelogram addition method to see if you get something that's approximately correct. But this method works too. You can just add together the I hat components, the j hat components. And if you're in 3D, you might also run into k hat. It's the same deal. It just corresponds with z. So hope that made sense to you. If not, you should go back and watch the adding forces vector. And if you did, you're ready to move on to the last method, which involves sines and cosines. So this method is probably the trickiest of all three methods for adding forces, but I'm confident that you can do it if you just think about it a little bit. So you're back to having two vectors here, one of which is 45 degrees above the x-axis, and has a magnitude of 5 radical 2. And I know it looks like I'm being mean to you by doing that, but I'm really trying to help. This will make your calculations easier in the future. And the other one has a magnitude of 3, but is 180 degrees from the x-axis. It's pointing the negative x direction. So take a second. It might take you a little while to solve this, but if you just stay calm and apply your trigonometry, you can really do this. So the first step is we have to break this down into the x and the y components. So what's the x component of force 1? So let's call this force 1 sub x. And that's a notation I'll probably use through the rest of the class when dealing with complicated vectors. So we can say is the x component is the cosine component. And this is because the x is the adjacent. It's adjacent to the angle. So we want to use COA. Cosine is we want to use CA. Cosine is the adjacent over the hypotenuse. So if we multiply the cosine times the hypotenuse, and in this case the hypotenuse is just 5 radical 2, then we'll get the adjacent answer. So 5 radical 2 cosine of 45 should equal 5. If your calculator spits out a weird number, make sure you're in degrees, not radians. And if you can't change it, 45 degrees in radians is pi over 4. So then what's our force 1 y vector? Well, we just use sine. Force 1 y is 5 radical 2 sine of 45. And that's just using so. Sine is the opposite over the hypotenuse. And you should be able to figure out my logic based on how I did the previous one. So that's also 5. And the final one is for force 2. We could use sines and cosines. It's easier to just look at it and realize it's negative 3 in the x direction, and I should be marking my vectors here, and that it's 0 in the y direction. And after this, we just go back to using the method we used last time. 5x minus 3x is 2x hat, and 5y hat plus 0y hat is 5y hat. So our new mystery vector is this, and it's going to look a lot like this, which when you look at them, makes a lot of sense, because we had one that was very large this way, and then it doubled back with the second one. So 1, 2, and then 1 plus 2. So I hope you got an understanding of what's going on with your vectors here. Being able to understand vectors easily is relatively important for a lot of physics, because you have a lot of vectors going on. So if you don't quite understand this, I'd really encourage you to go back and try to get a grasp of what's going on.